Here we're going to multiply two numbers together. 5 times the square root of 8 times the negative 3 times the square root of 3. And we're going to actually view this as 4 factors. The first one is 5. The second one's the square root of 8. The third one is negative 3 factor. And the last one is the square root of 3. So we can move those around. We have a property called the commutative property of multiplication, which says we can move things around. So let's move the numbers, the simple numbers in the front, 5 times negative 3. And then the two radicals we're multiplying, and they have the same index, so we can do the multiplication under a single radical, square root of 8 times 3. Well, 8 times 3 is 24. 5 times negative 3 is negative 15. So this is actually negative 15 times the square root of 24. Okay, that's nice. Now we can simplify the square root. 24 can be factored, and we can get a perfect square factor busted out of there. And so we can bust apart. The 24 is 4 times 6, so we get 15 times the square root of 4 times the square root of 6. See how we busted that apart and we brought the perfect square out in the front? Okay, so the square root of 4 is 2, so we have negative 15 times 2 times the square root of 6. The square root of 6 cannot be simplified any further, so let's just multiply negative 15 times 2. We get negative 30 times the square root of 6. Okay, so that's multiplying radicals. What about when you're adding radicals? Well, it's a little different because when you're adding radicals, you must have the same index and the same radicand. In other words, you have to have like radicals. Unlike radicals don't match. You cannot combine them. So you're looking for the same index under the hook, in the hook, and the same radical, the same value under the radical sign. Everything has to match. So our problem is 9 times the cube root of 24 minus the cube root of 81. Now, at first glance, you look at this problem, you go, this is not going to subtract. You cannot add and subtract radicals that are unlike. And these two radicals might have the same index, 3, but they certainly do not have the same radicand. The first one has a radicand of 24, while the second one has a radicand of 81. So should I just leave this thing alone? No, before you walk away from a problem like this, adding and subtracting radicals, you should try to simplify each of the radicals individually and see if you can get like radicals. And indeed, that's what's going to happen here. So the first radical, this cube root of 24, we can bust that apart. 9 times the cube root of 8 times the cube root of 3. Now we're able to do that because 8 times 3 is 24. And I brought the cube root of 8 in the front because I know that's a perfect cube. I'll be able to get a nice number from that. Okay, now just bring down the second term, minus 3 times the cube root of 81, which is 3 cubed. All right, so that means I'm going to cancel these guys. And let's see, what is that giving me over here? Okay, what I actually did here was I took that 81 and I factored it as 27 times 3. And the 27 I wrote as 3 to the third power. See, that's why I have minus the cube root of 3 cubed minus the cube root of 3. So I took the perfect cube and I brought it in the front. So you can see how now I've canceled the third power and the third root. Okay, let's continue with the next line. Bring down the 9 times the cube root of 2 to the third power. So here what I've done is I have rewritten 8 under the radical sign as 2 to the third. And you don't have to do that step if you don't care to. I'm just trying to be very precise. And then we're going to subtract the 3. Okay, let's see, 3 times the cube root of 3. So I'm missing a cube root of 3 before the equal sign there. Please put that in. I should have 9 times the cube root of 2 to the third times the cube root of 3 minus 3 times the cube root of 3. Okay, and then I would have 9 times 2 times the cube root of 3 minus 3 times that cube root of 3, which I forgot to put before the equal sign. All right, so continuing, this is equal to 18 times the cube root of 3 minus 3 times the cube root of 3. Okay, stop right there. Now we finally have like radicals. You see the two radicals and the two different terms that we're subtracting here are both like because they have the same index in the hook, 3, and they have the same radicand under the radical sign, which happens to also be a 3. It doesn't have to be the same number as the hook. It just has to match the radicand of each of those numbers. Okay, so we've got 18 of these radicals minus 3 of them. 18 minus 3, well, 18 minus 3 is 15. So our final answer is 15 times the radical cube root of 3.